Hello, everyone. Super excited to be here to talk to you today about OpenTelemetry, the latest milestones and what's next. I've been a part of the OpenTelemetry community since the very beginning, been in the observability space for a really long time, and I'm really excited today to talk to you about what's going to happen going forward with this project. So if you're not familiar with it, OpenTelemetry is an open standard that helps you with the generation, processing, and emission of telemetry data in your environment. It has three major components: the specification, where the open standard is defined, and then it has two reference implementations based on that specification. You have your language-based instrumentation libraries. These support all major programming languages, and this is what you would add to your code in order to generate the telemetry data that you care about. Then there's also a collection mechanism, primarily in the form of the OpenTelemetry collector, which is a way of processing that data and handling where it gets sent to. What's unique about this project is that it only really focuses on the telemetry data processing and emission point. It does not actually provide an observability backend. Instead, it plugs into a variety of different commercial and open source observability platforms that exist today. And if you've heard of the three pillars of observability, of course, it supports traces, metrics, and logs, but it supports way more, and that's what I'm going to focus on today. So what are some of the big milestones that have happened beyond kind of these instrumentation libraries, the collector, and traces, metrics, and logs? First, there's the OpenTelemetry demo environment, and version 2.0 has been recently released. The demo environment actually features all stable components within the OpenTelemetry project. It's a way to get your hands-on access to it and actually play around with the instrumentation, the YAML configurations, the code that you need in order to leverage the project. But it also shows off many other CNCF projects like Jaeger for tracing or Prometheus for metrics. And recently, Velki was added to replace Redis as another CNCF project. OTel Weaver is probably something you've never even heard of, even if you're involved in OpenTelemetry, but it's actually a very cool tool. It's a command line interface that's used to manage semantic conventions. This is something that you can add into your software development lifecycle. What are semantic conventions? It's basically a normalized way of naming metadata. For example, you have HTTP calls. Well, you have like a status code. What do you call that? In OpenTelemetry, it would be http.status_code. Well, there's thousands of different semantic conventions you're going to care about for HTTP, databases, functions, serverless, you name it, right? The project here is defining them and stabilizing them with HTTP conventions, database conventions, and exceptions already being stable. RPC will be coming next, and we have GenAI, CI/CD, and even mainframe semantic conventions actively in progress. But to manage all of this, it can be very, very difficult. For example, if you've ever dealt with a semantic convention that has changed for you, it breaks your dashboards and alerts. What do? Well, with the Weaver tool, you can actually add this into your software development lifecycle, where if you make changes that will actually break your dashboards and alerts, it will tell you. So it's a way of doing check validation. There's a lot of cool interfaces here that you can take a look at. So semantic conventions, I already kind of showed you HTTP status code. That's one of many. You have messages, functions. You also have resources in OpenTelemetry, infrastructure information, like what pod is this running on? What host is it running on? How do I name those things for Kubernetes, EC2 instances, or even virtual machines? All of these are defined in the OpenTelemetry project, and here's a variety of different commands that you can run in Weaver. I don't have time to show you them all, but there's actually a great YouTube video on this that was shown at the Observability Demo Day for OpenTelemetry this year. Next, we have the injector donation. So the injector is a way of adding auto instrumentation into your app at runtime. It's an easier way to get started with telemetry data. It's a donation from Splunk and worth taking a look at. There are OTel collection extensions for Lambda functions. So if you're familiar with Lambda or serverless functions, usually your instrumentation has to send the data directly to the backend. Now you can actually run a collector instance alongside your functions. This is useful if you want to do processing of the data beforehand and to deal with things like latency exporting your data. In order to do this, the OTel collector was extended with a couple cool capabilities. One is receivers that can actually receive Lambda data, and the second is this decouple processor that you see highlighted, which decouples the exporting from the receiving capabilities in the collector, allowing this to work in an environment where the function could be turned off at any time. Another cool thing in OpenTelemetry is known as OTel. This is basically a domain-specific language, or DSL, in OpenTelemetry. It's primarily for the OpenTelemetry collector, and it's a way of writing, instead of complicated YAML files, hopefully a simpler SQL-like interface. But even with that simplicity, context inference has been very difficult in the project. That is now natively supported with the SQL commands. The OpenTelemetry protocol has been extended with Apache Arrow. This is a way of decoupling the data to help with reducing the amount of data that you're sending, as well as ensuring that you have a more efficient data format end to end. There's demo environments of this for phase 1 and phase 2. And then finally, we have Golang instrumentation. It already supported manual instrumentation, but if you're familiar with compile time languages, it's kind of hard to do auto instrumentation. Now there are donations from Datadog and Alibaba Cloud, allowing you to do this via eBPF, as well as compile time injection. So be sure to take a look at the project. There's a lot of great things happening here, and a lot of advanced things happening, but the CNCF graduation ticket is actually available for this project. Please vote for it, and if you are already leveraging the project, consider adding yourself to the adopters page. Thank you so much, and I'll see you at the OpenTelemetry table in the Solution Exchange.